Okay, so I've just pasted the website to this the link, sorry, to this GitHub repository in the chat, so that after this workshop, you'll be able to come back and review these notes or use them at a later point. So there were some pre-workshop instructions that were sent out. So if you have followed them, feel free to try and follow along with what I'm doing. But if not, feel free to sit back, relax, and enjoy the demonstration and refer back to these things to try it on your own later. During the workshop, I have a few slides that I'm going to talk to that I've linked to here. And then I'm going to walk through and half demo, so because I didn't want to reinstall things on my computer on the fly on Zoom in case things went wrong, but I'll show you how I would install these things. And then the last thing I'll do after I show the installation and setup is show a couple, there's kind of like 3 different ways that you can use Python through RStudio with Reticulate. And then finally at the very end, it will be the third part where we're working on our Markdown. And I'm going to demo building our Markdown document from a skeleton that I've provided you a link to here to be able to use Python inside of our Markdown and mix both R and Python in the same document. So I'm going to move now to PowerPoint, to my slides to kick this off. And so let me go to, hopefully I didn't want presenter mode. Can I do this? Does this look good, folks? Can I get a thumbs up or a yes in the chat?
Looks great.
Okay, great. Okay, so the title of the talk is Reticulate RStudio and your R code with Python. And I'm just going to give a little outline here. So I'm going to talk in these top slides about, or this slide deck first, about choosing the best software tool or language for the job. And then I'm going to go through the other things that I mentioned just a minute ago. So when I think about doing data science, and I'm teaching students to do this, or teaching others outside of the university to do this, I talk about what are the kinds of tools that we need to do data science. So we need a programming language, we need a code editor, and we need version control software to do these things well and effectively. And so I like to list them as these things. These are the tools we need, as opposed to going over here on the right-hand side and saying you need R, or you need Jupyter, or you absolutely need to use GitHub to do these things. So I think that these are the groups of tools that we need. And here are some examples of the different software that fit into these bins. But kind of like my philosophy is that as long as tools satisfy criteria that I'll talk about in a minute to allow you to do your data science work, then you can use a variety of programming languages or a variety of code editors or a variety of version control software. Although I do have some personal preferences, in large part because of who I work with and what I'm familiar with. So when it comes to choosing the best tool for the job, again, I think as long as the tools allow you to meet the following 3 criteria, they'll be suitable for data science. So the tools need to allow you to do reproducible work and auditable work. They need to allow you to do your analysis in an accurate manner, and you need to be able to collaborate. So today, what we're going to be talking about will really be tools that allow for reproducible and audible analysis, and that's through writing code. These 3 points are nicely described and summarized in an article by Hilary Parker called Opinionated Analysis Development, and I think it's a great, wonderful paper that is a good read for everybody. So basically what I'm getting at is to allow your data analysis to be reproducible and audible, programming languages and writing code allow you to do that. And so you don't have to feel that you can only use one language. And what language should you use? Is there like a best language for data science? And I would argue that there's not. That in the case of the language wars, oftentimes people talk about between R and Python. In many cases, you can do something equally well, equally good in both programming languages. So how then do we choose what we should do? And my suggestion is to really just avoid the language wars, and that siloing yourself and siloing your work is worse than not choosing the perfect tool. So what I suggest is that you look at who are you working with and what tools are they using. And if they happen to be using Python, well then it would make sense for you to use Python. If they happen to be using R, then it makes sense for you to be using R. It also depends on, like, is there legacy code or projects that you're going to extend? If you're going to be working on a project and it's primarily written in Python, I think in that case, it makes a lot of sense to continue to extend that program in Python, and vice versa with R. And sometimes you'll end up working with teams where you have kind of like two camps. You have like the strong Python programmers and the strong R programmers. And it's nice to try and be flexible and to be able to move and communicate between those things. So Reticulate is a tool that helps facilitate that communication, in particular between R and Python. So that's all I was going to do with the slide deck. So at this point, I'm going to move on into, I'm going to continue to share, but try and exit out of PowerPoint and close PowerPoint down. Great. Okay, so what I wanted to share now is to actually get into using RStudio and Reticulate and show you how we do that. So I have RStudio open here. And so what I want to show you now is what you have to do to set it up after you have installed Python. So before we get moving forward with that, I just want to make a comment that in the setup instructions that I gave, I asked you to install a particular version of or distribution of Python. And it's not 100% essential that you use that exact distribution of Python. However, it's just one that's been that's widely used, been tried and tested across a lot of different people's machines. It has a big community behind it, and that's why I recommend it. Usually your laptop comes with some sort of Python installation, but it's usually not the most recent version. And so usually it is very normal that you would have a system Python that's doing a bunch of stuff for your operating system, but then you'll also install another Python distribution that's more, that's usually a newer version, and that might be paired with some sort of package installation manager that makes it really easy to install Python packages, for example. And so the package distribution that I recommended is called Miniconda, and it does have that. So in addition to giving you Python when you install it, it also installs a package manager called Conda, which you can use to install Python packages. And it does a nice, there are other ways to install Python packages, pip is an example, but it lets you, Conda is a little bit more powerful, or at least has been in the past, for like solving package version clashes and stuff like that. And it has also some other nice advantages that's kind of beyond the scope of this talk. Okay, so this demo is based on you installing Miniconda previously, and then I have assumed that everybody has done that. And so at this point, well, the next thing that we would do is install the Reticulate packages inside of RStudio. So we would use install.packages to do that, and then we would type Reticulate, and we would run this command. And I'm not going to run this command because I don't want to have a live demo. I don't want this to, for some reason, not work and have my live demo not have Python inside of RStudio and not be able to move forward. So what I would do at this point is install Reticulate. And if Miniconda is already installed, it should not kind of prompt you to install another Python, or even if it does still prompt you, I say like, well, can we install this for you? You can just say no, because we're going to do some things in a few minutes to tell RStudio where Python should be. There's a question in the chat that's asking, is PyCharm okay instead of Miniconda? Well, they kind of sit in two different worlds. So PyCharm is more similar to RStudio, whereas Miniconda is kind of like R that you downloaded from CRAN with a few other bells and whistles around it. You still need to run Miniconda through, you still need to run the Python that was installed with Miniconda through something on your computer, through the terminal or through some sort of IDE, which RStudio is one option. Great question. Okay, so I'm not going to run this install.packages Reticulate, but I would encourage you to if you're following along. And then the next thing that I typically would have to install is the PNG package. This is something that isn't always required with Reticulate. It seems to be, at least in the last month or so, a dependency that I've encountered that wasn't installed along with Reticulate, even though perhaps it should be. So if you run into, you can either install this now, it won't hurt you, or if you run into trouble later, you can come back and see if installing the PNG package might help you get out of that trouble. Okay, so once we have these things installed, then we need to tell basically R which Python to use on your computer, okay? And so to do that, one thing that you can do on a Mac or Ubuntu or Linux operating system is open up the terminal. If you're on Windows, then you would want to open up, I gave in the install instructions that I set up to install a program called Git Bash, which gives you more like a Unix type terminal on your computer. And so I would encourage Windows users at this point to open something called Git Bash. And you want to ask where that miniconda lives on your computer. And we can do that by saying which Python. And that is going to give you the path for where miniconda is installed on your laptop. And so you'll need to copy that to your clipboard, and we're going to use that now to set up an environment variable in our R profile so that every time R starts up, R will know where this miniconda distribution of Python lives, okay? So I'm going to just set this off to the side now and continue here. So the next thing that we want to do is you can do this without use this, but I'm going to recommend we use this to edit our profile. I'm just seeing another question in the chat. So if you're in Windows, you want to open, instead of terminal, you want to open Git Bash and type the same thing, which is which Python. And yes, I'm talking about miniconda here, which is a Python distribution, but Anaconda is also another Python distribution from actually the same group, the same organization, and it should work the same way as miniconda does here. Yeah, good question. Okay, so now we're going to open up and edit our R profile. So you can do this yourself, but sometimes it can get tricky as to know like where exactly this file should live. So the use this package has some nice helper functions to make sure that you create our profile file in the right place. So we'll say use this edit _ our profile here. And when I press enter here, what is going to happen is that a new file is going to get open if you've never done this before. If you've done this before and you've put things in your R profile file before, it will open that file and you can just add these things there. So I'm going to hit enter now to do this. And what you want to put in your R profile is this line up here, okay? So sys.setenv, and then we want to say the environment variable. So we need to say what, we basically want to say reticulate Python should always be this Python, as opposed to your system Python or something else. And maybe I'm just realizing as I go along, I am kind of ticking through this list of instructions, which is in the repository, but I should point you to the right file. So I've just pasted in the chat the instructions that I am going through right now, so that you can copy and paste some of these things as well. Okay, so if you're on a Windows machine, you're going to need to set things up a little bit differently. And actually, it's really cool that Reiko is on the call because Reiko helped me troubleshoot this problem, I think 2 years ago. So with my students, so thank you so much. So on Windows, you'll still use sys.setenv. You'll still use reticulate Python, but you need to specify the path in this way. And the key things are that you're using these double backslashes because you're going to have to escape some sort of parsing that is happening. And then the other thing that's really key is that you need to add this .exe on the end of the path, or it's not going to be able to find or execute the Python as well. So these are a couple of nice nuances for Windows. Windows is always a little bit special. It's definitely usable, just a little bit different. Okay, so now that we have our profile set up, you would save this file and then you can shut it down. However, this file gets loaded when you start R. So to have R actually be able to use it, you're going to need to restart R. So I'm going to close this down and I'm going to go to session and I'm going to click on restart R. And so now, from now on, every time when you start R, it's going to load that R profile file, and the environment variable for reticulate _ Python will be the miniconda or anaconda distribution of Python that you have installed.
Hi, Tiffany.
Yeah.
There's a quick question in the chat about if there is a way to set environmental variables to switch between Python versions. If this
There,
is the point in which you defined that, or
yeah, there are, and this is where I'm going to say like it's where I'm going to have to go and look at the docs. So there's kind of a couple different ways you could do it. So you could have maybe a couple different environment variables that specify different things. But another way to handle this is kind of through a combination of Reticulate and Conda. So Conda is installed along with Miniconda or Anaconda, and it's the package manager that I talked about. And it's more than just a package manager. It's also a basically like a virtual environment tool. So you can, through Conda, create different virtual environments that have different versions of Python and different versions of the Python packages that you need for different projects installed. And then you can use Reticulate to interact with those environments. So maybe what I can do near the end is point you to where in the Reticulate docs that is, because I haven't used that very recently. Does that sound good? And answer the question? Perfect. All right. So now we're partway there. So now we're set up in a space where if we wanted, so like this is called the REPL right here in the console where we're, this is an R REPL where we can like type in code, like, I don't know, print hello. I can type. That's an R REPL. We can set up now, hopefully, a Python REPL and start working with Python code interactively here. So maybe I can demonstrate this at this point. So how you would need to do that is you would need to load the Reticulate library that we have installed. And then what we need to do is there's a function that goes REPL_Python. And when you type this function in, you're going to notice that this cursor, or this, I guess, prompt, is going to change. It's going to change from 1 caret to 3 carets. And that's like very conventional of Python. So if you're using Python in another IDE, you'll see that it's using those 3 carets as an indicator of the Python prompt. So let's go ahead and do this now. And if you have correctly set up your R profile, installed Miniconda, installed Reticulate, all of those things, you should see these 3 points here. And I think I'm just checking my notes to make sure I'm not missing anything from Windows. So that should get you that far with Windows as well. So now we're in Python, and I can say x equals 7. I can print x, and I can import. Maybe I can't make this a little bit higher. I could import a Python package. So one we'll talk about later is pandas, and we give it a nickname PD typically. Oops. And what you can see, which is pretty neat now, this is actually really new. This didn't exist a year ago. So this is very exciting, is that the environment pane that you're probably very used to using for looking at your R variables now works also for Python. So this is pretty new as of just a few months ago. So that's very exciting, or at least I'm very excited about it. Okay, so this is giving us some functionality, but there's probably more we want to do. Another thing that we often want to do is be able to call Python scripts from the terminal, okay? So we'll do a little, I'll demonstrate that after we finish this setup. So I'm gonna go to the terminal here, and maybe I'll clear everything. And if you type which Python, I've already gone through these setup instructions. What you really want to see again is your Miniconda or your Anaconda version of Python. However, when you first set this up, this typically isn't the case. You need to do a little bit more. So what do you need to do? Well, it depends again what operating system that you're on. So if you are on a Mac or a Ubuntu or Linux operating system, one thing that typically works is by changing your bash _ profile. So I'll just give a little demo of that here. So when you install, yes, sorry, I should say this is, yes, I am running the RStudio preview version. So there's a comment in the chat that this environment pane here, seeing the Python variables, is in the preview version of RStudio, which anybody can download and use. And I would recommend it because there's a lot of other really cool features with this preview, including on-the-fly rendering of your Markdown documents inside of our Markdown, which would be really nice. Okay, so inside of your terminal, you want to go to your home directory, and a trick to get there is just typing cd, and that will bring you to your home directory. And I'm not doing this inside of the RStudio terminal, I'm doing it out here just to make sure that sometimes these two things don't give you the same thing for home depending on what operating system you're on. So I'm going to type cd, and then I'm going to, let me see, I'll probably just this should work on Mac, I think, as well as Ubuntu, and then I'll talk about Windows. We want to open up our bash profile. So we type nano bash _ profile. And if this file doesn't exist yet, you could make it, but it should exist if you have installed Miniconda and Anaconda. And what you're going to see inside of there is a lot of things. It doesn't look very fun, but the thing that you should be looking for is this Conda setup here. And so Conda has changed how it sets up your machine from the last couple of years, and it's trying to be a little bit more gentle and basically not take over the path for which Python to look. But to make it work within RStudio, or at least as much as I've been able to troubleshoot it, we do need to be more explicit. So really what we need to do is, instead of having this very gentle control flow here, looking at what programs can access it, I want to go back to how Conda used to say what Python should be in my path by typing this export path equals, and then the path to my Miniconda version of Python. So we have to specify that there in the bash _ profile. So when you set that up and you save this file and you were to restart a new terminal inside of RStudio, and I'll talk about that because this is very important for the Windows users as well, you should see then that you're getting the path to the Python that you've specified here also showing up here when you type which Python. So I'm going to type Control X to get out of here. And now, I'm going to shift gears and talk a little bit about Windows users. So let me pull up this appendix here. So I'm going to pull this in so that we can I have a demonstration here. So in Windows, things are a little bit different. So in Windows, it's not going to be by setting the bash profile that's going to show the git bash terminal or the bash terminal inside of RStudio where to look for Python. You need to set up what's called a custom terminal. So inside of RStudio, and I'll go show this now, and then I'll flip back to this document. Under Tools and then Terminals, you should be able to go to Terminal Options, okay? So Tools, Terminal Options. This will open up the pane that I'm previewing for you in this document, which I'm going to flip back to in a minute. So inside of Windows, you want to do that. And then you want to say that the new terminals are going to open with custom. And then you need to use this browse to find where the bash.exe is. And it's usually here under Program Files, Git, bin, bash.exe. And then you have to add this -l command. So once you do all of that and you click Apply and OK, then what you need to do is restart R and then go through this Tools terminal and then open a new terminal. Because one of the key things to read up here is it can't change the terminal that you're using on the fly. You need to open a new one. So that means inside of RStudio, like I would want to shut down this terminal. So I have no terminal here now. And then I would go to Tools, Terminal, New Terminal. And I would get a new terminal, which is going to be the git bash, which is going to be able to see the correct Python when you type which Python. So I'm just going to draw my attention to the chat because I'm seeing some questions for a minute. And then we're going to, now we've done all the setup, we're going to actually get going on using Python a little bit more inside of RStudio and mixing it with R. So someone is asking if I have some existing text in the bash profile to set up the path. So maybe what I can just do is I can just quickly, this is how I would set it up in the bash. I'm just pasting it into the chat, export path. your path to Python. I guess one key thing to point out, so maybe I'll just again highlight this. This is the line that you, on Mac and Linux that you need to add to your terminal, is that you don't actually go all the way to Python here. You go until the folder that Python lives in, okay? You don't want to go all the way into bin Python. This path should be going to a directory, which is, for my computer, opt miniconda 3 bin. Hopefully that helps. Okay, so now we are presumably set up and we are able to start doing things inside of RStudio with Python. So let's go back to the console and remember now that we have a Python console open. Y'all, hopefully everyone can see it and it's not too low here. Maybe it's just my Zoom bar that's bothering me. Is we're able to type in this Python code, but what if you want to go back to using R now that you have set up Python and I want to play around with some R code? Well, how I can get out of this REPL terminal is I can type exit. And when I type exit, you can see that my environment pane changes. So I'm back in the R environment and you can see that the prompt has changed as well. So now it's just a single caret. So now I'm in the R environment. And so I can go back and forth between Python and then typing exit to go back to R and use these things both in the REPL. So, but typically you're probably not used to just typing things into the REPL, probably like playing around with things. But when you're developing your code, you want to be working in a script or in some sort of literate code document, like an R Markdown document. So you have a record of what you typed in, because once you type it in and press enter, it kind of goes off into the world, and then it's hard to get it back unless you can remember it perfectly, which I never can. So what's cool about RStudio now is that not only can you create R scripts, we'll create an R script that we can play around with, but you can also now create Python scripts. And what is cool is that RStudio now recognizes which is a Python script and which is an R script. So if we're going to be in an R script and say, we probably want to load the tidyverse, for example, because it has a bunch of packages that we want. And then maybe here we want to import pandas as PD, which you can kind of think about as the equivalent as the tidyverse in R. If I'm in R, I'm used to being able to control enter, for example, to send my commands from a script to the REPL so that I can play around with things. What's really cool is that, again, now RStudio recognizes what type of script you're in. So if I use Control Enter to run some code from a Python script, you see that the REPL changed. That's really neat. So it immediately recognized that this code was being sent from a Python script, so I should change the REPL. And if I go back to my R script, the same sort of thing happens again. So it's like you can go back and forth, and it's very convenient. So you don't have to have like two separate developing environments for using these two languages, which is very nice. Okay, so that is how we are running. We can run code we can develop code in a script and then test it interactively. We can also, for example, I wanted to show you that you can call scripts. So I'll just print hello again, very important script. And I'm going to save this very important script, call it test.py. Okay, so we have test.py in the terminal. Now that we have our Python set up, we can easily run test.py and it will import pandas and print out hello. And we could do the same sort of thing with RStudio. We could save this as an R script and then also through R script, the script name, be able to run it through the terminal. So that's kind of like setting up your environment and your RStudio so that you're able to use the console and the REPL there to interactively test your code as you're developing these scripts, and then be able to run things. Yes, you could source the script as well, or call your scripts through the terminal. Now, maybe I'll just pause here for a second, and then the next thing I'm going to go on to talk about is our Markdown documents. So this is probably a good point to pause and just answer any questions that might have. You can throw them in the chat or raise your hand in the participants panel. All right. If nobody has any questions, I'll keep going. I just want to check in with the hosts that people can still hear me.
Yep.
Perfect. Okay. All right. So why don't we go into now seeing how we can run some more interesting Python code inside of an R Markdown document and mix the two languages. So I have set up a skeleton document on the GitHub repository that you can use. And where we're trying to get to is, maybe I'll just go here. And I will.
We've also got a question about setup on the RStudio cloud when you have a minute.
Okay, sounds good. Maybe I'll do that at the very end here. I was just going to show you what we're getting to work towards. So we are working towards creating this Markdown document that you can view here on GitHub, which is a very simple, went from a R Markdown document to a Markdown document that that imported some Python code, that used Python to read some code, uses Python to create a data visualization, then decides, hey, I like ggplot, so I'm actually going to use ggplot with this Python data to create a visualization. Do some subsetting inside of pandas to grab pieces of our code, and then I'll show you how to do some inline Markdown text when your object that you're wanting to reference is in Python. So that's where we're going, and so now I'm going to open up that Markdown document, and we'll get started there. Okay. Just navigating back here so that I'm all set up, and just want to make sure that because we're actually going to be typing code. Is that a good enough font size for the audience?
Yeah, I think that looks good.
Great. Okay, so I have a bunch of text and skeleton, which might be interesting for you to read later, pointing you to places where you can go and learn more. But I'm going to start by editing the code chunks, and then we'll run things one by one. Oops, this isn't the right one that I want. I want the empty one. Perfect. Then we'll go through running things one by one, knitting things one by one, or running things one by one to see how this goes. So the first thing we need to do is we're going to load some libraries, and we're going to load these libraries in R, even though we're going to be primarily using Python. So one of the libraries that we're going to load should not be a surprise, which is going to be Reticulate. And then the second library that I'm going to load is going to be ggplot. Not that it's needed, but I'm going to show you how you can use R and Python to mix together, and I'm going to do that using ggplot as my demonstration. So what I'm going to do now is kind of run this like a little R notebook, use these play buttons, but if we run into trouble, I'll just knit the document, and that will be how we test that this works. So we get no errors coming out of here, so we assume that everything was well, and we'll learn that as we go further. So now we have the tools that we need in R to get going to use this document. The next thing that we need to load is the Python library. So Python is a little bit different than R in that it wasn't a data science or statistics language first. It was kind of built as a more multi-purpose language. And so, for example, it doesn't have some of the base data structures that the R programming language has. So it doesn't have data frames in the base Python language. So to be able to have a data frame and to be able to have some nice functions for using and working with data frames, we need to load a library. And the, I guess, most well-developed and the most user-friendly library that I'm aware of in Python for doing this is pandas. So to load the pandas library, we're going to type import pandas. And that's all you need to do to load the library. So that's like akin to saying like library ggplot or library tidyverse. However, it's very common in Python that sometimes these import statements are quite long and verbose. And so they give what are called aliases to the things that you import so you can reference them more quickly and easily. So when you're doing that, you want to use the kind of alias that the community uses so that when other people are reading your code, or when you're looking through the help docs, or if you're looking through Stack Overflow, that you are able to search and find for the same kind of code that you're using, which will depend on the alias you choose. So we say as to specify is a special word in Python so that you can give it an alias. And the alias most commonly used with Python is PD. So I'm going to run this line of code, and we can see that what's interesting is we get a little kind of like bit of information from R that it was able to use the Python REPL to run this code inside of the R Markdown document. and that we can be happily aware of what version of Python is using. It's the one that we set up our computer to use. Okay, so now we have our R packages loaded. Now we have our Python packages loaded. What we're going to do next is try and load some data, okay? So we're going to use none of the R read functions. We're going to use a Python read function to do this. So we're going to, I have some Titanic, very exciting Titanic data set. So we're going to use Titanic. And I'm going to use, they have a read underscore CSV function in pandas, just like we do, just like R does. So we can use the read underscore CSV function, but there's something a little bit different that we have to do. We have to say where this is coming from in Python. So this is coming from the pandas library. So even though we have imported pandas as PD, we still have to say that it's coming from PD. And if we didn't use this alias PD, then we would have to write the full thing out pandas here, okay? And then what we do is we pass a path to the data file that we want to read. So for us, the data file lives in data, and it's Titanic CSV. Okay, so let's hit the play button to see if we can successfully read it. And what we can see over here is that the data frame is showing up here inside of our environment pane, which is pretty cool. And we can see a little preview of the data set as well. So that's pretty nice. We can also, preview it. So we could have it be printed out inside here. And it has a nice print method inside of RStudio as well. So it doesn't like print the entire data frame out. If you were really wanting to control in Python how you do that, there's a head command, but instead of, it's a method actually. So instead of like wrapping the whole object in head like you would in R, it's .head at the end. This isn't this workshop isn't meant to teach you Python, but I just thought I would explain some of these little nuances as we go. One thing that I'll point you to is that if you're interested in learning more, in this R Markdown document I've given you some links where you can go to start to learn more. So the Pandas docs have this nice 10 minutes to Pandas guide here, and then the group that I work with has started to create some interactive free online courses for Python and data science. So this one is about learning how to do data science programming using the Python language. So feel free to check that out if you're interested in learning more. Okay, so now we've loaded our data and our data exists in the Python environment. Let's use Pandas to create a quick data visualization. So Pandas itself isn't a data visualization library, but it has some wrappers to another data visualization library that's a little bit more complex and heavy to use called matplotlib. So it has some nice easy functions that we can just take advantage of that will call matplotlib for us and make something like a scatter chart or a bar chart or something like that. So let's go ahead and use Pandas to make this a quick, easy scatter plot to get going. So we'd say the name of the object, and this is pretty nice. You can see that even though I'm in Python inside of RStudio, it's starting to fill in the objects, so I can take advantage of tab completion and not make as many errors. And then I'm going to use the plot function. And again, you can see that it's showing me all of the methods and attributes that are available for this kind of object in Python. And so RStudio has really come a long way in making this a nice, really developing environment for Python. And then I'm going to do scatter. So titanic.plot.scatter. And then I'm going to say what I would like to plot. So I'm going to plot age on the x-axis, and I am going to plot fair on the y-axis. And there's a lot of points, so I'm going to, similar to ggplot, you can specify what the alpha is, so you can have some transparency of the plot. So one thing to note, there's a really big difference between these languages, is you notice when I'm referencing the column names in this data frame, right? You can see the column names. Well, here's some of the column names. These aren't the ones I'm referencing, but P-class, survive, body, home desk. Those are all column names in the Pandas data frame. I have to put those in quotations in Python. So R is a pretty special language, and that, and especially in the tidyverse is even special within R, and that you just are able to use these unquoted column names. There's a lot of actually stuff going on behind the hood that allows for this, and that isn't something that's commonly done in Python or very well implemented. So in Pandas, when we're referring to our column names, we have to put them in quotations. All right, I know this will work if I knit from top to bottom, but I haven't tested this on the fly plotting, so it doesn't show up yet, okay? So if we want to do this, see what the plot would look like, I'm just gonna remove this so that I don't get an error later on, and I'm gonna knit the document, and you can take a look at what the pandas visualization looks like. So here I've knit the document, we imported our library, we previewed the data set, and then here is our data visualization that will show up just like one would show up if we created it in R. Okay, so what if we don't want to plot with pandas? What if we don't want to plot with matplotlib? We'd rather plot with ggplot. Well, we can also do that, which is pretty cool. So let's start talking about how we could do this. So there's a special reticulate syntax that's like this. Pi $, I have a typo here, object. Pi $, the object that you want to reference from the Python environment. And R can go into basically the Python environment and access that object, which is pretty useful and pretty cool. So we can do something like this, where we can say ggplot, and then I'm going to, where do I need to get, where's the data set? Well, the data set's in the Python environment. So I have to say pi $, and then I can reference the Titanic. And it's really cool. Like as soon as I say pi, I'm just gonna do that again because it's so cool, pi $, I can go down and find the some of the, or at least the objects that are accessible to me from R in the Python environment. So here's the data set. And then because I'm in R, I can now use that data frame like it's an R data frame. So inside of this function call, so I can say AES and I can say X is going to be age, and I don't need to quote the column names like I typically would in a ggplot call. And I can say Y equals fair. And so this is really nice, so that if you're needing to mix these two codes, two different languages, because say you have some collaborators that are really good at machine learning code and they're writing that in Python because that's where most people have been writing machine learning code for a while, or many people have. They want to do that, but you're like the data scientist who's really good at doing beautiful ggplot data visualizations. You could use something like this, but to easily mix your code together. So let's do geom_point to make it a scatter plot. And let's see if this runs in line. And this does in fact run in line. So this didn't run in line. So I think there's still a lot that needs to be developed inside of our Markdown to render. That's kind of like the weakest point of this tool chain at this point, is including visualizations in line here, and sometimes even in the render, depending on the plot library. But there is our ggplot object that we created using a Python data frame, which is pretty cool. Okay. Keep moving along here. The next thing that we're going to do is just a little bit more exploring of Python. So just to talk about, again, highlight some differences of how you would do things with common functions in R versus common functions in Python. So one common thing that you would do in Python or in either language, or task, I guess, is to like subset your data. So say we wanted to subset some columns in Python. Well, to do that, we would take our data frame, and instead of using a function like select, what's most common is that we use this square bracket notation. So we would say the name of a column we're interested in, and again, we have to put quotations, and we'll grab two of the columns we're interested in. So this single square bracket notation on the inside is making a list in Python, and then that list is being used to subset the data frame. So that's what's happening here. And then we're able to get just two columns of our Python data frame. And then if we want to select rows, there is a function that's called query, or a method that's called query, that is very similar to filter, but it's not as commonly used. So what I'm going to show you is more commonly used to filter rows. So what's more commonly used to filter rows is going to be taking the name of the data frame and then square bracketing. It's kind of more like base R syntax, and then saying, okay, this is the column that I'm interested in. Say we want people whose age were greater than 70, and then we put our equality here. So this is the data frame, and then we're going to subset it for the rows where this statement is true. And then we're able to get the 6 rows in the data frame for the Titanic passengers who were greater than 70 years old. Okay, So the last two things I'm going to show you is how do we go in and get like a single object, and this will highlight another really interesting difference between the R and the Python programming language. And then I'll end with showing you how you can do inline markdown inside of with Python inside of R Markdown.
Tiffany, I was just going to say this might be a good moment for a couple of questions from the chat.
Okay, yeah, maybe I'll pause there before I go to the next step. Yeah, that's great. So let me bring my attention to the chat. Yeah, or you go ahead.
And I think you answered at least one of them about the accessing different objects across the different environments. It seems like, yes, you can do that. There's certain syntax for doing it. But there's a question about the zero indexing in Python and how that comes into play.
Perfect. That's actually where I'm going next. So I will talk about how Python counts next, and that's in the next example. And then, so somebody, I will comment on, I guess it's Elisa's question. So she was commenting about like how we can go back and forth. So from again, I'm not an expert on Reticulate, so I've always used it in a way that I'm sometimes using R to reach into the Python environment. I haven't used it in a way where it's going, I don't think I have, the other way around. There is another library that is older than Reticulate called rpy2, and it's a Python package. And that package is designed to go the other way around, where you're primarily writing Python code and you want to call you want to use a little bit of R in your Python code. So that's where what I've seen more to go the other direction. Great questions. Okay, so let's move forward to talk about how we would find the destination of the first passenger. So let's remind ourselves here what Titanic looks like. Oops. And so what we're interested in getting is basically St. Louis, okay? This is the very first passenger, that's like the very first row of the data frame. That's really interesting if you go over, and it's already hinting to us in the print outlook here that these are indices, which are kind of like row numbers you can think of in R, and it's giving you a 0 here. So why is it giving you a 0 for the first passenger? Well, there's kind of like two camps of programming languages and how they count. Some count from 1 and some count from 0. Actually, a lot of them count from 0, and Python is one of the 0 counting languages. And so the first row when you're trying to index in Python is actually the 0 row, so you need to reference 0. And then the second row is actually labeled with label 1. And so when this is probably one of the bigger gotchas. This and the unquoted column names are like the two things that when you're starting to write Python code that can really trip you up. And maybe in our chat later on afterwards, another person on this call who might be really have a lot of great insight as to, maybe even more so than myself, as to like what are some of the biggest gotchas when you're learning these things in parallel would be my past student Reiko, who's on the call, because in the Master of Data Science program that she took, we teach both of these languages in parallel at the same time. So it's definitely an added challenge. Okay, so we're trying to get St. Louis here, which is in the home.dest column, and we want this first row, which is the 0th index. So how do we do that? Okay, actually, I'm going to keep working here. So what we're going to do here is, again, we're going to use square brackets to index the column name. So I'm going to say home.dest, and we have to quote these. And then I can use a numerical index here to grab. So right now, this would be grabbing a single column. Maybe I'll do it one step at a time. So this will just be giving us the home dest column. And so if we want to get this first record here, we would use square brackets to index it, and we would say 0, okay? And so instead of 1. And that would give us this one string here, which is St. Louis, that we would like to use. So yeah, it's a very tricky thing to remember and get going, that Python counts from 0. Okay, so what I'm going to go to next is, so what if there's often one of the great powers of R Markdown is that if you're writing a report, that instead of like, and you're iterating over your analysis and the numbers are changing a little bit each time, that you don't need to like yourself, if you want to discuss like what a p-value is or what your test error is inside of the text part, instead of like typing that out and like copying and pasting it each time from the code output, we can use inline R Markdown to do this. So if you were doing this with an R object, the syntax to do that would be -R and then the R object name. And then if I could, Oh, I did spell that correctly. And then if you actually had something that was called R object inside of an R code chunk, that value would be, when you rendered the document, would be printed out here, which is really useful and really cool. So, but how can we do this if the value that we want is actually in Python? So what we have to do again is use that special reticulate syntax, the $, to reach into the Python environment and go ahead and access what we need. So right now I can't access this actually because it has no name. So let's give this a name so I can actually reference it. So we'll call it first_dest, and we'll say equals, and then I can use this here to reach into the Python environment and grab it. And this is going to have to be demonstrated from knitting the document because it won't show up here inside RStudio. So let's knit the document now. And if we scroll down to the bottom, instead of $first_dest, we actually get the value from first_dest that gets printed out here in inline markdown. So that's pretty nice and pretty cool. So I'm going to pause here at this point again and see if there's any other questions or comments for a minute or two. And then there's like one other thing I'm happy to show if we have time, just to generate some discussion. All right, so it seems as though there's no questions at this moment. So what I'm going to do is go here, and I just want to show you, this is some demo code that I had for a demo project for my courses. But what this script is it's a script that's doing some machine learning, and it's written in R, so it's an R script, but it's using the most widely used machine learning library or package in the world, which is scikit-learn, which is from Python. And so I just want to I'm not going to run this code, but I'm just going to highlight that in this R script that I would import the R libraries, but then you can also use Reticulate to import the Python library. So there's these functions in Reticulate called import, and then you would give the name, instead of doing in your Python script, it would be import sklearn as sklearn, or just import sklearn itself. You would put that here as a string. And then we can access these libraries later on. So we now have three basically Python library objects here. And if we go later on, here I'm creating a k-nearest neighbors model by taking that Python library that I've imported and then accessing functions from within it. So this is another way that you can maybe even go deeper in mixing your R and Python code. So again, you can imagine that you're doing this project that you're most comfortable in R, but maybe there is some new machine learning algorithm that's only available yet in scikit-learn and Python. And it probably will get implemented in R, but either you have to do it or you have to wait for somebody else to do it for another 6 to 8 months. So instead of waiting, what you could do is use Reticulate to be able to access these new Python functions inside of your R code, which is pretty neat. Okay, so that's kind of all that I had planned to demonstrate and show. So I'm happy to have a chat, take questions, play around with things. I do see a couple new questions in the chat, so I'm going to answer the ones that I can. So Ayush is asking, is it safe to assume that Reticulate would work with Flex dashboard since it works with R Markdown? And that's actually something that's out of the scope of my knowledge. So I do not know the answer, Ayush, but if anybody else on this call knows the answer, I would love to hear it. Or if not, when you do find the answer, please do ping me on Our Lady Slack or on Twitter and let me know the answer. That's a great question. And Kyle is asking, can you repeat why my RStudio version shows Python objects in the environment tab? Right. Okay, so I said that when I'm in the Python environment here, I'm able to see like the Titanic, and this is something that's really new. Like this wasn't even available 6 or 8 months ago when I was teaching using RStudio with Python last year to my last year students. So if you go to, let me see if I can safely navigate. So there's the RStudio preview. So when you install RStudio, you can go to the RStudio website and go to the regular downloads. But if you're willing to live a little dangerously, but it's not usually too dangerously because they test these things pretty well before they release them as previews, you can go here and you can download basically the bleeding edge of RStudio that is almost ready to go into production in the next release cycle. So I'm running probably not this one, but somewhere, I don't know, maybe down here a bit off the page, but RStudio 1.4. So at RStudio 1.4 and forward, you do have this very cool ability to see the R environment things. The other thing that you can see, I don't know how well it's going to work in this mix document that also came out in 1.4 is this what's called this visual markdown editor. So you can click this switch here and it's going to change it to, sure, we'll say okay to this, to looking like rendered markdown, but you can still run and edit your code inside of here, which is is making it even more closer to what a Jupyter notebook looks and feels like. So, which is really, really neat and really cool. It's still imperfect and it has some kind of like small bugs with latex. So again, you're kind of like living on the bleeding edge, but it's pretty nice. And you can always flip back to regular to see if like any of the sort of the latex that you're putting in there is causing any typos. Yeah, great question. So Umar is asking, can we do Python package installation inside of RStudio? That, again, I think you're getting to the edge of my knowledge. I would point you to the Reticulate docs to see if that's possible. My way of doing it, again, is kind of like, it's nice to be able to use R with Python, but there are some really nice Python tools that is going to make your Python life really easy. So Conda is the way that I would use to install things. So you can do Conda install NumPy, for example, which is a numerical numbers package. And so that's kind of my way of installing packages. And I would be doing it. So it's an interesting nuance that's different too of choices that are made with the language. So how do we install R packages? We're typically inside of an R environment using installed packages, an R function to install packages. That's not how you do it in Python. So in Python, you're at the command line and you're either using conda install or probably even more widely used than conda and has become improved. So I might become more of an adopter of doing this because it has some new features that makes it more similar to conda, but pip is also another way to install Python packages. So I am still doing it here in the RStudio IDE, but I'm doing it inside of the terminal. Great question.
Thank you so much. This is really cool. There have been so many amazing features that you've talked about today that I did not know existed. I had a quick question about if you're working with a data set in pandas, is it like Python where you're not like loading this into memory, or is it like R where when you create an object, then this is being loaded into memory? Do you?
Yeah, so if you're in Python, whether you're doing it through how I just demonstrated through RStudio or some other environment, Jupyter or something else, when you do pd.read_csv, you are loading that data set into memory. Yeah. In both languages, if you don't want to do that, you have to use some sort of other tool that will kind of like let you peer into the data set and kind of do like these filter and select things, and then you would collect them back into memory. So, the deep IR front ends for things like SQL databases and Arrow would let you do that. And then there's equivalents in Python for basically hooking up and connecting to a database. There's also PyArrow, which is like Arrow in R, that would let you look at these bigger data files, do some selecting and filtering, and then collect things back into memory. Great question.
And it seems like there's another question up here about saying, I would like to automate navigating websites and understand there's a Selenium package in Python. Would Reticulate be useful in this case too? I'm
gonna, again, be very honest when you're getting to the edge of my knowledge. So my only experience using Selenium is as a dependency for a really nice plotting package in Python called Altair. So I demonstrated using pandas plotting because it's really simple and easy to get up and get going. But the library that we now teach in our program and use is called Altair. It's really nice. It sits on top of Vega in JavaScript, which sits on top of D3. And there's also an Altair package and Vega package in R as well. It's still a bit limited in its interfacing with R Markdown. So you can create objects, but actually getting them to render is still quite problematic. So we're having discussions with the developers of Reticulate and our Markdown to see how we can work around that. So I'm optimistic because it's such a great package that we can make these two tools work together. Well, they can make these two tools work together for the community in the near future.
Great. And then we also have a question from Ava wondering if Reticulate is scalable in your experience, or if you think it's best for exploratory work. Is it about relative to R, what's it like in terms of speed?
Yeah, so I mean, I think I've demonstrated a couple different, so I think you have to ask about like in which way you might be using Reticulate. So if you're using Reticulate to help you only have to, so what do I love most about Reticulate is that, as you've probably all experienced, there is a barrier to learning a new IDE. It's silly, but there is. Like, you have to know what to click and where things go and the shortcuts till you're like really effective. And I feel really effective using RStudio, but there's a lot of projects I work on that I have to use Python for. And so I've used other IDEs, but I just feel very slow and not very good at using them, and it slows down my work. So now what I really love about Reticulate is that I can basically use all of my shortcuts and skills in RStudio that I'm very comfortable in, and then I can just flip the language and everything still works. So I think that aspect of RStudio is getting to the point where you could almost write production level Python code using the RStudio IDE. Okay. The using Reticulate to mix R and Python code and in a script like I was showing you for that machine learning script, that definitely is working for exploratory stuff, but I cannot comment on if I would put that in production in some sort of medical or that sort of thing, commercial operation yet. That I can't comment on.
Great. Well, if there are any last questions for Tiffany, feel free to chime in or type them in the chat. Also, if you have any general comments about Our Ladies or things you'd like to see from us in the future, or comments about this, then feel free to reach out to us either on Slack, which is available, or come to our future events. Oh, we have another question asking if Reticulate works well in an R kernel Jupyter notebook.
I would imagine that it should, to be able to use this kind of like what I was showing you in the the last R script that I showed, where I'm mixing sklearn in with a bunch of R code. I think that should work fairly nicely inside of an IR kernel. But yeah, of course, you wouldn't be able to do the R Markdown type stuff within the Jupyter notebook, because it just doesn't have, it's not, or at least that I'm aware of. That's kind of more of the case where I've seen it the other way around, where people are running a Python notebook and they're using RPy2 to mix in some R. I think you could do it now the other way around with Reticulate, where you're writing an R Jupyter notebook and mix in some Python. Yeah.
Great. Well, Margaret, is there anything, any last words you'd like to say?
Just thank you so much for that presentation, Tiffany. That was really wonderful. You're getting tons of props popping into the chat box.
Thank you,
too.
Everybody.
It seems like people really enjoyed it, and it's awesome that we have access to the materials. If people are having a hard time finding stuff, or just shoot us an email or post a message on Slack. Join the Slack workspace if you haven't already. Oh, sorry, I should turn my video back on so you guys can see me. And I guess otherwise, thank you so much, Tiffany. We'll have another meetup next month in January. We have, for the first 4 months, we have something every month for next year. So we just look forward to having people join us. It was really fun having people from all over the place not just in current Baltimore residents. But yeah, hopefully we'll get a chance to meet in person someday, Tiffany, too.
I'm optimistic and hopeful. Yes.
Yes, I hope so.
All right. Thank you so much.
All right, thank you.
Thank you all.
Enjoy the rest of your day, everybody.